The important capabilities that we need at this point are related to all aspects of the mission. The first two important capabilities we need are heavy lift vehicle for launching large masses into space, and we need a crew vehicle that's appropriate for these types of missions beyond Earth orbit and the return to Earth at high velocities. So the vehicles that we are undertaking right now are the first critical steps in that process. Beyond that, once you're in space, there are other technologies that are needed. It's important to get to very efficient in-space propulsion. Very high efficiencies are needed in order to keep from having to launch large masses of fuel from Earth to orbit. So that can, if you talk about trips to Mars, efficient in-space transportation can cut in half the amount of mass it takes to go to Mars. Once again talking about Mars, aero capture in an atmosphere, being able to slow down once you get there using the atmosphere itself to slow down rather than doing it with rocket engines that use fuel is an important technology. In space, closed-loop life support reduces the consumables that it takes to support a crew for long periods of time. So life support systems are important. Once you get to a place like Mars or another planetary body, the idea of using resources that are there in creating fuel or some consumables that you need during the flight is important, because you don't have to carry them in that case. So on the moon there is water ice, we believe, in the dark craters. We believe there is water and ice at Mars. Water beneath the surface, ice near the poles. Those are sources of hydrogen and oxygen you can use for fuels, or you can use for consumables for the crew. Other technologies are many. Precision landing, hazard avoidance. In order to land safely on another planetary body, whether it's the moon or Mars, is important. And it also allows you to go to more interesting places than we normally land. The places that we've landed, both human spacecraft during Apollo and now with robotic spacecraft, we generally go to places we think are going to be safe for the lander to land. But if we can land in a very interesting or very dramatic landscape with precision, knowing where we're going, and land very carefully and be able to avoid big giant boulders or rocks that would get in the way, then we can go to more interesting places than we've even been before. So those are important technologies. One area of research that's extremely important is understanding galactic cosmic radiation effects on people. It's one of the tall poles in long space exploration. When you're in Earth orbit, you're protected from it to a large degree by the Earth's magnetic field. But once you're beyond that magnetic field, you're in that environment. And we actually have it mapped pretty well. We understand that environment pretty well. But we don't understand the effects on human cells very much at all, actually. So that's an important area of research that we'll need to make progress on before we send people on very long missions.